Hi, this is Mr. Mack. Now this is the concept video that deals with some of the basic properties of logs. Once again, I'm going to show you these properties, and I don't think there's any way to show these to you without actually proving them. And then I'm going to refer you to the solution videos to see these in operation. It is very important that you watch the solution videos here. Now, the book says the first property of logs that you need to know is that the log base x of the product AB, in other words, we're multiplying A times B, and then we're taking the log base x of it, can be rewritten as the log base x of A plus the log base x of B. Now, this is what we'd like to prove. And this is a property that can be proven, and I don't really believe that a good, strong honors class in algebra or algebra 2 would be complete without actually showing a proof of this. But before we start, let's just talk about it for a minute. Remember, the fundamental concept of a log is that a log is an exponent. Now notice, we've got a base of x, and we're taking the log of AB. So what we've got here is the log of a product of things with the same base. Now, if you're multiplying exponents or exponential expressions, and you have the same base, the rule is you add the exponent. So notice the log of the product is the sum of the logs of the two factors. In other words, this is very much like the concept of when you're multiplying powers with the same base, you add the exponents. And since the logs are the exponents, that's what you actually do. So now, for the proof, this is what we want to prove. Let's start with something that you and I can both agree on. What I'd like to do is I'd like to take a couple of variables that aren't being used in this expression and assign them values. Let's let the log base x of A be equal to R. And let's let the log base x of B be equal to S. Okay, now, this is allowed because R isn't doing anything at the moment and S isn't doing anything at the moment. So we can let R and S be assigned to those values if we want. Now, because this is true, if we rewrite this logarithmic equation in exponential form, we'll get x to the R equals A. And if we rewrite this equation in exponential form, we'll get x to the S is equal to B. Now, A times B is equal to x to the R times x to the S, because I'm just substituting x to the R for A in this equation and x to the S for B, then that's allowed. Now, I'm going to take the log base x of both sides of this. Now we have log base x of AB is equal to the log base x of x raised to the R. Oh, let's go back here for just a moment. I skipped a step. X to the R times x to the S is x to the R plus S. That's the rule of exponents. If you're multiplying and the base is the same, you add the exponents. So let me write this again. A times B is equal to x raised to the R plus S. Now, I am going to take the log base x of both sides of this. So the log base x of A times B is going to be the log base x of x to the R plus S. Now, we're going to use our understanding of the definition of logs again here. We have the exponent on x that gives x to the R plus S. In other words, we're asking the question, what would you put on x as an exponent to get x raised to the R plus S? Well, obviously, it would be R plus S, right? So we have log base x of AB is equal to R plus S. But now what is R? Up here we have R right here, r is equal to log base x of a. So I'm going to put log base x of a where r is. And what is s? Well, according to this one, s is the log base x of b. So I'm going to put log base x of b here. And on the other side, I'll just write what we had there, log base x of ab. But now, if you look at this, this was exactly what we started out to prove. That the log base x of a times b is the log base x of a plus the log base x of b. So anytime you are taking the log of a product, you can split that product up into factors and add the logs to the same base. And that becomes very, very useful. Now the second property is like it. It is that the log base x of a divided by b is equal to the log base x of a minus the log base x of b. Now I'm not going to prove that one in this video. What I would like you to do is I would like you to sit down and look at the proof of the blue proof and see if you can't do the green proof. It's so similar that if I were to do it, you would say, well, you know, it's just really the same thing with division and subtraction rather than multiplication and addition. It's something that you could do very easily, but also realize what we're saying here is we're taking the log of a quotient. You can split it up into the log of the numerator minus the log of the denominator. Okay, now this next one is really the one that makes logarithms so extremely useful. This is where the rubber meets the road, as Goodyear would say, or where the water hits the wheel, as the riverboat captain would say, or where the fertilizer hits the inclined helix. Anyway, this one, number 3, log base b of the quantity m to the p is equal to p times the log base b of m. Now, look at this with me for just a moment, because this is really pretty amazing. What we're doing is we're saying that if you have the log of a power, that this power, the exponent, can actually come out and be a coefficient in front of the log. Now, that helps us in solving equations where the exponent is the variable. So that's why logs are so powerful. Now, we want to prove this, and once again, this is what we want to prove, so we need to start someplace where both you and I can agree. Let's do this. Let's let log base b of m be equal to some variable that's not being used at the moment. How about r? Now, that's allowed because r wasn't doing anything. We can let it be that if we want. Now, if that's true, however, the definition of logs tells us then that m is equal to b raised to the r. Now, what I'm going to do is I'm going to say b raised to the r raised to the p is equal to b to the pr. Remember, when you're raising a power to a power, the rules of exponents say you multiply the exponents. Now, I'm going to take the log base p of both sides of this equation. So I have log base p of b to the r to the p, and I have log base b of b to the pr. Now, on this side, I'm going to point out that b to the r is m. So this left-hand side becomes log base p of m to the p. Now, on the right-hand side, what we're going to do is we're going to use our understanding of logs again. What exponent of b gives us b raised to the PR. Well, obviously PR, right? Because you put PR as an exponent on b to get b to the PR. So this would be PR. But what was R? Well, right up here we have R is equal to log base b of m. So I'm going to replace R with log base b of m. Now over here, the equal sign still works, so we have log base b of m to the p is equal to p times log base b of m, which is exactly what we wanted to prove. And so what we showed was, if you're taking the log of a power, you can just take that exponent and put it out front as a coefficient. That's extremely, extremely powerful. Now, these properties, along with the concept of solving logarithmic equations and all that kind of stuff, will enable you to do lots of stuff that you couldn't do before. Watch the solution videos carefully, please. And that takes care of the concepts for 8.5.